Okay. So today we will discuss what question related to irrational number for exercise 1.2 of class 10 maths chapter number 1. This is last exercise of this chapter. I think you know yesterday I also told you what are irrational number. The real number which are non-terminating, non-repeating and non-reoccurring is known as irrational numbers. Some teachers telling what's the definition of irrational number. They are saying the real number which are not rational. Both are right. But that one depend on what rational number. If you know about rational number, then you can tell which is not rational. You can say that one is irrational. But exact definition of this is this: the real number which are non-terminating, non-repeating and non-reoccurring. Yesterday told you one theorem. Again I want to revise. If P is a prime number and P divide A square, then P divides A also. On the basis of that theorems, we already proved under root 2 is irrational, under root 3 is irrational. Now in exercise question number 1 given, prove that under root 5 is irrational. Same process like that same process like that under root 2 and under root 3. But I can tell you what's its solution. Let, if possible, under root 5 is a rational number. What's a rational? If it is a rational number, then definitely able to write in this form. P by Q you can say, where B is not equal to 0 and A, B are co-prime integers. Co-prime integer, co-prime meaning nothing is common between them. Prime and understood? So we can write like this. This is your first. Squaring both sides. Of equation first. Which is equation first? This is the equation first. So, what's its square? Under root 5, B, under root 5 square is equal to 5, B square equal to B square, B square is equal to B square, and this is A square. This we can write yes or no? So by that theorem, by using theorem, if P is a prime number and P divides A square, then P divides A also. Therefore, 5 is a prime number, 5 divides A also. And this we can take this equal to C. And what's its meaning? A equal to 5C. Understood? So putting the value of A equal to 5C in where? In equation second. Yes or no? So what's its become? Put here 5b square equal to, in place of a we can write this. So 5b square equal to 25, c square 5 cancel this. So b square equal to 5, c square. What about c? C is an integer. Yes or no? So again this 5 bring in this side, b square by 5 equal to c square. What's its meaning? By using same theorem, this theorem, p also divisible by 5. b also divisible by 5. a also divisible by 5. b also divisible by 5. But what? According to our assumption, a and b are co-prime integers. So contradict. Hence our assumption is wrong. So what we can say? So root 5 is a irrational number. Understood? Simple proof. Definitely coming question in your exam. It may be 2 marks, 3 marks, 4 marks, what it may be, but definitely coming. Yes or no? Understood? Now next, you have to prove that question number 2 of exercise 1.2. You have to prove 3 plus 2 under root 5 is a irrational number. So again solution. What we can say? Let if possible, what? 3 plus 2 root 5 is a rational number. If it is a rational number, then we can write like this. This we can write 2. This we can write 3, take in this side here, plus mean here minus 2 root 5 is equal to a by b minus 3 by 1. So what's your answer? B is your, what's B? B is your LCM. So a minus 3b. Yes or no? In next step, it's meaning this become this a minus 3b by b. So 2 also take in this side, a minus 3b by 2b. This is equation number first. What about this LHS of this? LHS of first under root 5 is a irrational number. Irrational number or not? What about this? This is definitely irrational number. Why? Integer minus integer is an integer. Divide by integer. So what's coming? Rational number. But RHS of first, that is a minus 3b by 2b is a rational number. Yesterday told, is it possible rational equal to irrational? Not. We can compare only when both are like term. So rational and irrational are unlike term. Hence, our assumption is wrong. Therefore, 3 plus 2 root 5 is a irrational number. Got so much easy portion. If you can understand each and everything, you know definition. If you can do ratification, not possible. But if you can do creativity, try to understand creativity meaning, then easily able to solve. Next question of this exercise, third and the last question of this exercise. 3 parts given. First part is this, second part is this, third part is this. So one by one we can prove these, taking solution of first part. You have to prove 1 by n root 2 is a irrational number. You can say let, if possible, 1 by n root 2 is a rational number. If it is a rational number, definitely able to write. So you can write 1 by n root 2 equal to a by b. Here b is not equal to 0 and a, b are co-prime integer. Got? Yes or no? So this take in this side. So it's become 1 equal to n root 2 a by b. Yes or no? B bring in this side, b equal to n root 2 a bring in this side, b by a is equal to n root 2. What is this? Again, this is, you can say first, RHS of first, that is n root 2 is irrational. You know, already proved it. What about b by a, integer divided by integer? Definitely a rational number. So LHS of first, that is b by a, is a what? Rational number. So what's its meaning? So our assumption is wrong. Is wrong. Then what? Therefore, 1 by n root 2 is a irrational number. Easily you can prove. If you understand, then no problem. Understood? No doubt. So look here, second part of this question. Erasing this. Second part's what saying? You have to prove 705 is a irrational number. You know that root 7 is irrational. So rule this also, rational into irrational is always irrational. But solution I can write. Let, if possible, 7 and root 5 is a rational number. If it is a rational number, then you know we can write in this form. Here, A, B are co-prime integers and B also not equal to 0. If B become equal to 0, you know what happens. So this I can write A by 7B We know LHS of first, that is under root 5, is a irrational number. We know RHS of first, that is a by 7b, integer divided by integer, definitely rational number, is a what? Rational number. Is it possible rational equal to irrational? Not possible. So what we can say? So our assumption, what's our assumption? 705 is a rational number, is wrong. If it is not rational, what is that? Irrational. Therefore, 705 is a what? Irrational number. Got? I think understood. Easy also. Erasing this now. So next part of this exercise, next part of this question and last part of this exercise, you have to prove, what you have to prove? 6 under root 2 is a irrational number. This also so much easy. So solution, let, if possible, 6 plus under root 2 is a rational number. If it is a rational number, then easily we can write 6 plus root is equal to, in the form of p by q. Here b is not equal to 0. A, b are co-prime integer. So this we can write like this: a by b minus 6 minus 1, 6 here plus in this side. Transform from left hand side to right hand side, so its sign changed. If it is a plus, then become minus. If in multiplication, then we are gone in division. Under root 2 equal to b is your LCM, a minus 6b. Again first, LHS of first, that is under root 2, is a already proved irrational number. If in exam, it may be possible you have to prove first. That depends upon the marks of the question. Then you can easily prove RHS of first, that is a minus 6b by b. It's integer minus integer, again integer, divided by integer, again a rational number. Is a what? Rational number. Therefore, our assumption is wrong. 6 plus root 2 is a irrational number if it is not rational. So this is all about this chapter. I told you what I told you. Important definition. 2 theorems given. One is the fundamental theorem of arithmetics. That one saying what saying? Every composite number we can write as a product of primes. And this factorization is unique apart from the order in which they occur. It's meaning every composite number we can write as a product of primes. And this factorization is unique apart from the order in which they occur. Second theorem, if p is a prime number and p divides a square, then p divides a also. So use of both theorem in this chapter, both are important. Both solution not coming in exam. but they're huge coming in exam. With the help of second one theorems, we proved how can they are irrational. With the help of first meaning fundamental theorem of arithmetics, we are able to prove theorem number 2. I think you understand. If not understand, revise this. All definition: rational, irrational, natural number, whole number, integer, prime number, odd number, even number, composite number. Then also you have any problem, then you can discuss with me in any form. Tomorrow we can start next chapter, chapter number 2. First we will do basic of that chapter. So thank you all of you.